Hey guys, Mr. Milton here. Today we're going to talk about trig ratios again. But today we're going to be able to find missing measures using trig. And you'll be able to differentiate between when to use inverse trig functions and when not to. Okay. In the previous lesson, we learned about how to find the missing sides. Today we're going to talk about finding missing angles. Okay. So we're here and we have an unknown angle, x. We want to write the equation of this. Okay, our trig ratios are still the same. Remember SOHCAHTOA. We are given the adjacent side and the hypotenuse. And so adjacent and hypotenuse means we're going to use cosine. Our equation is going to be cosine x, because that's the angle that we're looking from, equals the adjacent 15 over the hypotenuse 17. Notice that the variable is by the trig function, by cosine. Okay. Getting the variable by itself is going to require something called an inverse trig function. Okay. We cannot divide by a trig function since sine, cosine, and tangent are simply descriptions. They are not numbers. Okay, they are not numbers or values by themselves. Okay. Now, let's take this back to algebra and help us to connect what's happening here. Okay. We've used inverses before. Hopefully you've known it. It's called inverse operations. But we know that to solve this problem, you would divide both sides by 3. And that's because dividing both sides by 3 is the same as multiplying by 1/3. Okay? But 1/3 is the same as 3 to the negative 1. You guys remember that as your exponents, your exponent rules. When you had a negative exponent, you could rewrite it as 1 over 3 to the 1 to make it positive. This exponent is called an inverse function. Okay, and so now, using the equation from above, let's get rid of the trig function. And this is what we have. So our equation from above, and I'll just start here, was cosine x equals 15 over 17. Okay, in our algebraic problems, we said, okay, well, we have to multiply both sides by the inverse. Okay, in our trig functions, we're going to do the same thing. We have to take both sides by the inverse. Cosine 15 over 17. Okay, on this left side, we basically are able to cancel out the cosines. Cosine and its inverse cancel out. And now, in our calculators, you'll notice that you have that blue. If you have this TI calculator that we say it, just above cosine, you have that -1, cosine to -1. So put second cosine, and now in your calculator, you enter your fraction, 15 over 17, and you'll get to the nearest tenth, 28.1. Now let's just do to the nearest degree because it's an angle. You'll get 28 degrees. Okay? So the only time we use the inverse trig function is when you're trying to find the measure of an angle. That's the only time that you're going to use the inverse trig function, when you try to find the measure of an angle. Okay? Let's do some practice with this. Okay? And make sure you pay attention to the instructions here, as they will tell you how we want the numbers done. Okay? So we're going to try to find x to the nearest degree for number 1. So for number 1, we're looking for angle A. We're given an opposite and an adjacent. And so we'll say, okay, opposite and adjacent, that's tangent. Tangent x equals opposite over adjacent. 300 over 400, or you could do 3 over 4. That simplifies it a little bit more for us. Okay, 3 over 4. Okay, and so now to get x by itself, I'm going to do inverse tangent to both sides and inverse tangent of 3 over 4. Okay, my calculator, as I type that in, and I'll just show you guys here, the inverse tangent of 3 over 4 is 37 degrees, 36.86, but to the nearest degree is 37. And just to ease your mind, the inverse tangent of 3 over 4 is the same as the inverse tangent of 300 over 400. Okay? So that doesn't change anything. Just makes less things for you to type. Okay? And that's why simplifying those ratios helps you as well, or can. All right, next problem. We are going to find angle B to the nearest 10. Okay, so notice that they don't have a variable written down for us, but I'll insert one in here just so I know what I'm looking for. Okay, so I'm looking for angle B. I have the opposite of angle B and the hypotenuse to angle B. And if you want to write all those out every time and just say adjacent here and then just use what you have, then that's fine. I usually don't add extra letters because I don't want to get confused with which ratio to use. So opposite hypotenuse, that's sine. So I'll say sine of z equals opposite 12 over hypotenuse 13. And so now, since I'm trying to find an angle, I'll do inverse sine 12 over 13. That gives me 67.38. The directions tell me to find it to the nearest tenth, so 67.4 degrees. That's the measure of angle B. All right. Okay. Let's look at number 3. Number 3, they want us to find x and y. Okay, and so we're given an angle here, 36, and y is our opposite, x is our adjacent, 7 is our hypotenuse. And so to find x, I'm going to say, okay, adjacent and hypotenuse, that's cosine. Cosine of 36 equals the adjacent x over the hypotenuse 7. Okay, and I'll go ahead and solve that. That's 7 times cosine 36 will give us x. 7 times cosine 36 is 5.66 to the nearest hundredth. That's 2 decimal places. Okay, and then to find y, that's opposite and over hypotenuse, that's sine. Sine of 36 will be the opposite y over the hypotenuse 7, and that's 7 times sine of 36 will equal y. Can I just change that to sine? Let's see. Yeah, it worked out. And that's 4.11 to the nearest hundred. Okay. Notice for this that we were finding side length. And because we were finding side length, we did not need to use inverse sine or cosine. We didn't need to get rid of sine or cosine. Okay. Now, for number 4, we'll be finding angles again. Okay. So for number 4, do that one for me. Okay. Bring that in, complete it tomorrow. Set up your functions, set up your equations as we've been doing, and then give me your answer so I know that you listened and you can kind of do this on your own. Okay. Number 5. Let's do this together. Number 5 is just kind of a word problem doing the same thing. You are standing 500 feet away from the base of a giant redwood tree that stands 350 feet tall. What is the measure of the angle formed from the ground at your feet to the top of the tree to the nearest degree? Okay, so our picture, we got a redwood. Imagine this like that. We're standing 500 feet from its base. It says it's 350 feet tall. Essentially, we have a triangle. Okay, and it wants to know the angle created by our feet. I'm going to put x there. And so what I have here is my opposite side and an adjacent side. Okay, this would be a 90-degree angle. Redwood stands straight up, at least that's how we measure how tall it is. Okay, and so opposite and adjacent tell us tangent. So I'll say tangent x equals the opposite, 350, over the adjacent, 500. I could simplify it down more if I'd like to. You can do what you want there. And so now I need to get rid of tangent, so I'm going to use inverse tangent. Inverse tangent of, I'll just say 35 over 50. Save myself a little bit. Inverse tangent of 35 over 50, not times 50, divided by 50. And that will give me 34.99. So to the nearest degree is 35 degrees. Okay. All right. So that's that. Pretty close to finding the side length. So extra practice there with recognizing the ratios. But notice and remember that when we're finding the angles, that we do need to use the inverse functions. Okay. Again, if you're having trouble with getting the same numbers, make sure your calculator's in degrees and not radians. And I'll see you tomorrow. See ya.